Okay, here's our first video for section 6.5, which involves a lot of stuff with radicals, also known as roots, such as square roots, cube roots, fourth roots, fifth roots, etc. So first, let's look at a couple of the rules. We've been using these before, so hopefully these look familiar. But if you take any positive numbers, a and b here, then multiply them together and take the square root, you'll get the same thing as taking the square roots separately and then multiplying them together. So a quick example of this would be if you have, let's say, the square root of 9 times the square root of 4. That's something like the right side of this. We're just going to check that we get the same thing as the left side. But anyways, the right side comes out to be, well, the square root of 9 is 3, and the square root of 4 is 2, so 3 times 2 is 6. And then if we multiply them together first, that would be 9 times 4, and the right side would look like the square root of 9 times 4, like so, and that is the square root of 36, and that is also 6. So that's an example of that one working. Let's look at a quick example of this one working. Let's say we take the square root of 9 divided by the square root of 4. So we're still using a is 9 and b is 4. That will give you 3 over 2, also known as 1.5. And if we want to get the left side of this, the square root of 9/4, we can check that with a calculator. The square root of 9 over 4 comes out to be 1.5 as well. So that just checks that one works. Okay, so those are a couple of rules. There's also an important thing that is not a rule. The square root of a sum, a plus b, if it's added here, you can't split that into the sum with addition of two other things. So this is not a rule, and you can just check it. If we've done this before, but if we could just check it with 9 and 4 again, I guess, and say the square root of 9 plus the square root of 4 is 3 plus 2, also known as 5. And then on the other side, if we do the square root of 9 plus 4, that gives you the square root of 13, which is approximately 3.6. So those are not the same thing. So that means that be sure that you don't distribute radicals like that. So let's look at an example of how you use these to simplify things. So let's say you want to do the cube root of 108. So let's see. If we're going to use that rule above, then the cube root of a times the cube root of b would be the same thing as the cube root of ab. So the trick is to make it so there's like an a that you can pick that is a perfect cube. So it will help to factor 108. Say what are some numbers you can multiply to get 108. So maybe you remember how to do an old school factor tree where you try to get numbers that multiply together to make 108. Well, I notice a 3 goes into that. Or actually, I know that 9 goes into 108. So let's see. 9 times 11, is that 108? Oh, no. 9 times 12 is 108. So that I'm going to write this here as 9 times 12 like that. And then you can keep factoring these and get 3 times 3. And then 12 is also 3 times 4. So this shows you what you can, these are all things you can multiply together to get 108. So in other words, 108 is 3 to the power 3 times 4. I say 3 threes because there's 3 of them here you can multiply together. So, or it's also known as, of course, 27 times 4. You could do it that way. So that's what we're going to do, is try to make it so the a here is the 3 cubed, also known as 27. So we can say the cube root of 108 is the same thing as the cube root of 3 cubed times the cube root of 4. And the cube root of 3 cubed is just 3. The index here basically cancels out with the power. So you get 3, and that times the cube root of 4. So that is now a simplified version of that. And generally with these, the goal is to figure out in this case, because it's a cube root, you need to find a perfect cube factor of 108. Maybe you don't want to do it with a factor tree, maybe you have your own ways, but there's other ways to try. Here's another exercise. It's pretty similar to that last example, except this time you're trying to find a perfect fourth root factor of 80. So let's give it a shot on your own. If you get the wrong answer, that's okay. Just cross it out and then write the right answer next to it. And let's try that now. Here's what I did. I got 2 times the fourth root of 5. By the way, make sure it doesn't look like 2 to the 4th power, because that's a different thing, of course. Anyways, I noticed that 80 is 2 times 40. I stopped with a 2 because that's a prime number, but then 40 is 8 times 5, and 8 is 2 times 2 times 2. So that's how I figured out what the factors of 80 are. And I noticed I could write that as 2 to the 4th power times 5. And that means that, hey, 2 to the 4th, that's a perfect 4th power. So the 4th root of 2 to the 4th is 2. And so that just gives you 2 times the 4th root of 5 when you split it up into 2 separate radicals like that. So that's the end of this video. Thanks for watching.